Right, welcome back. So if I've done this right, we'll have looked at some of your sketches. We'll have discussed what you can see in there, and what I'm going to show you on this slide is the answer based on a lot more time and a lot more work than we've had in the last session too, where you've made your sketches. So here we can see three benches of sandstone. Those are the three I picked out earlier. Here they're given different colours, and you can see they're also assigned names or letters to basically help subdivide the stratigraphy. You can also see a number of measured sections, so labelled 1, 26 and 19, superimposed on the cliff face, and those same logs are shown in here, 1, 26 and 19. And you can see that the lowest of the three sandstones, that's Roda W, which is coloured in green. That's shown as thinning and pinching out from left to right, which again is consistent with what we can see in the hillside here and hopefully what you have in your sketches. The overlying sandstone, that's what I labelled as number 2 earlier. That's shown in red here as Roda X, and you can see that is also thinning and pinching out from left to right in the correlation panel, and that's borne out by what we can see here in the hillside as well. And the upper sandstone unit, that's Roda Y. That's more continuous. In the correlation panel it's shown as thickening slightly from left to right as we go from measured section 1 to measured section 19, and again that's borne out by what we can see in the hillside in here. Hopefully we've discussed these different points already. How can we explain those lateral variations in sand body thickness and bedding, and how can we identify the effects of those heterogeneities? So I'm not going to answer these questions. Hopefully you've done that already. Okay, so I'm now going to return a little bit to the younger Oligocene cis conglomerates, which we said was in a unit called the Cisperia Valley, or in a feature called the Cispadia Valley. And that's one of 3 similar paleo valleys which trend north-south, and they sort of overlie and cut across thrust systems along the northern margin of the various basins in the south central Pyrenees. So those paleo valleys, including the Cisperia valleys, they're considered to be the main sort of routing systems. They're the main areas through which sediment, coarse clastic sediment, was fed into the Tremp-Graus Basin. And that they're intended to be long-lived features. So potentially, the oldest rocks that we see within that Paleo Valley today are Oligocene, but there's a large unconformity at the base of that, lots of missing time there, and it's reasonable to infer that there may well have been rocks which are older that once occupying that Paleo Valley, or that valley acted as a conduit to feed sediment at older times into the basin, potentially even during Roda Sandstone deposition. The composition of the class that we see within the Oligocene conglomerates indicates that basically erosion was taking place in the axial zone. So we're seeing carboniferous rocks, for example, metamorphic rocks, which are basically being exhumed, and the erosional products have then been transported through the Paleo Valley. Okay, there's an overlying unit, the Colligats conglomerates, which overlies the cis conglomerate, and that has a class composition which indicates that it was sourced from the external zone of the Pyrenees. So we're not seeing metamorphic rocks, for example. We're seeing basically reworking of some of the Cretaceous and early Tertiary rocks, giving us provenance for those conglomerates. So here we are, Cispadia Valley in the background again. You've seen this picture already, the Cispadia Valley. Here you're seeing a sort of nicer feature of that from a slightly different vantage point, picked out by snow. You can see the bedding really nice and clearly within the Cis conglomerate. And this block diagram here sort of is quite a nice graphical reconstruction of what that Paleo Valley might have looked like. So you can see that it's quite a deep feature. You know, we're talking about a valley which is probably in the order of half a kilometre to 1 kilometre in depth. You can see that the horizontal scale and the vertical scale are the same in this block diagram, and you can see the scale at the bottom there. That valley was effectively confined within very mountainous terrain, and if we look at the bottom part of the block diagram, you'll see there's an underlying structural control. So there are basically thrusts, or this is really a breaking between two thrust sheets, which are acting to create the surface topography, which keeps the valley confined to this position for a long time period. Just to go back a little bit to what I was saying earlier about provenance and whether the deposits moving through the Paleo Valley were being fed from the external zones of the Pyrenees or the internal zones of the Pyrenees. These are two block diagrams. The top one would be for relatively small catchments. So here, these catchments are eroding into limestones in the thrust sheets in here at the bottom. So those would be within the external Pyrenees. That's then being routed through potentially the Cisperia Valley or Paleo valleys like that. That's feeding sediment into, in this case, showing alluvial fans, and those alluvial fans are confined at the right hand end of the diagram by another structurally controlled feature over here. So that would be the equivalent to the Colligats conglomerate. That was younger than the Oligocene conglomerates we see in the Cisperia Valley in the present day. And then if we look at the bottom picture in here, this would be more comparable to what we see within the Cis conglomerate itself. So we have erosion of limestones and associated strata within the thrust sheets in here of the external Alps, the external Pyrenees even. And off behind those we see much more deformed rocks, which have been much more deeply buried and then exhumed within the internal Pyrenees, internal zones of the Pyrenees, and we're seeing effectively a much larger catchment. Sediment still being fed through the Cispadia Valley and similar Paleo valleys, and then because I have a much larger volume of sediment, that's basically it's moving further out into the basin, so it's overwhelming the structural relief further out towards the right hand side of the diagram, and effectively we're overfilling the basin and we're exporting that sediment much further south, and that sediment would end up essentially within what is now the Ebro Plain. So that's the next basin further south of the thrust confined basins that we've been looking at mainly. So that's just to give you an idea about how we might reconstruct the sedimentation history and link what we see in the catchment, what we see in these transfer systems of the valleys, the Paleo valleys, through into the basin fill stratigraphy. And I'm going to stop there. We're going to move on to 5.2.